Okay, let's see what happens if you insert the dielectric material at constant potential. For instance, if you get a battery and you connect a battery to the initial capacitor before you insert the dielectric material. Now, you insert the dielectric material while the battery is connected. So this is very different than the case we took before when the capacitor plates were at constant charge and they were isolated from any circuits. Now in this case you're connecting it to a battery. So the charge doesn't have to be the same on these plates. So after inserting the dielectric material, the capacitance will have a new value C. If the dielectric constant is K, what's the value of the capacitance C? Now we know that when you insert a dielectric material inside a capacitor, the capacitance increases by a factor of K. We took this before for the case of a capacitor. With a capacitor you insert the dielectric material at constant charge. Now it doesn't matter once you've inserted the dielectric material inside the capacitor. It doesn't matter what you do with it after that. Remember, when you insert the dielectric material, now you're living on a new curve, on this curve. It doesn't matter the way you inserted the dielectric material. The final result is that the capacitance is bigger by a factor of K. So in this case, when you insert the dielectric material at constant potential, you're starting out here where the capacitor didn't have the dielectric material, and you're inserting the dielectric material, so you're keeping the potential difference constant, but you're increasing the charge to a new value. So the reason why the capacitance increases in this case is because the charge increases. But the capacitance is K times C naught. Whenever you have a capacitor filled with a material that has dielectric K, constant K, then the capacitance is K times C naught. This doesn't have anything to do with the way the capacitor is connected. It's just due to the fact that the capacitor has a certain dielectric material inserted in it. So this is the situation before you insert the dielectric material. There was charge Q naught and minus Q naught on the plates. After you insert the dielectric material, there's going to be a different amount of charge Q and minus Q on the plates. And if you get the initial capacitance, it's Q naught over delta V. Now, when you get the final capacitance, it's different charge. The charge now is not the same, but the potential difference is the same because we keep the capacitor always connected to a battery during the insertion process. So let's see how the capacitance, because the capacitance is K times C naught, let's see how the charge will be different from the initial situation to the final situation. So if we substitute C by Q over delta V, and we substitute C naught by Q naught over V, delta V, we get this relationship. The delta V's are the same, so you get the relationship that the charge, the final charge, is K times the initial charge. So when you insert a dielectric material at constant potential, the potential difference stays the same by default because the battery always maintains a constant potential difference across its terminals, but the charge on the capacitor plates will increase by a factor of K. Where did this extra charge come from? It must have been supplied by the battery.